Hello, this is Mrs. Huntley. This is Module 6, Lesson 2, Constructing Scatter Plots. You should be on page 7 of your supplemental packet for this part of the module. And this lesson is going to be all about constructing our scatter plots. And if you remember, yesterday we talked a little bit about what a scatter plot is and looked at some examples and looked at some associations of data on the scatter plot. Just to dive a little bit deeper into it, what a scatter plot is it's a part of a coordinate plane, or maybe it's going to be the entire coordinate plane, but right now on the examples that we're looking at today, we're just looking at the positive x's and y's on a coordinate plane. And we're going to put pieces of data onto that coordinate plane and then see if there's any relationships or associations between that data to help us make predictions or help us to interpret the data and see if there is an association or there is not an association. Also in yesterday's lesson, we talked a little bit about dependent and independent variables. So before we get into today's lesson, I just want to review that really quickly, and hopefully if you have any questions about it, you've asked me about it, but if not, let's just try to explain dependent and independent a little bit more carefully. So let's think about the words dependent and independent. And the example that I like to use is with regard to financial independence. Now, most adults that have a full-time job are financially independent. And what that means is they earn enough money to pay for their housing and pay for their food and pay for their car and their other things that they want to do. Most students or children are dependent on their parents or guardians to provide those things for them. So the children are dependent on the parents, and the parents are, for the most part, independent. And again, I'm speaking in generalities. Of course, there are some situations where we have adults that might be dependent on other people for one reason or another. For a long time after I had my family, I was dependent on my husband because he was the only one that was working a job that brought income into the house. So financially, I was dependent on him. Anyway, let's get into the lesson and see if actually constructing some scatter plots will help us to make some better sense out of this material. So looking at the first example, Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So we have all of the basketball players, the distance they stood away from the basket, and the number of baskets they were able to sink. So looking, I've got a partial coordinate plane here. This would just be the positive x and the positive y. And it says use the data in the table to make a scatter plot, then answer the questions that follow. So now that we've talked a little bit about dependent and independent, which of these variables, the distance or the number of baskets sunk, is dependent upon the other one? So let's think about this. If I'm shooting baskets, am I going to be more accurate generally if I'm closer, and I'm going to be able to shoot more into the goal if I'm closer or if I'm farther? Or will the number that I can get into the goal determine how far away I'm standing? That's completely backward. So the distance has got to be my independent, and the number of goals I make is my dependent variable. The dependent or the independent variable is always your x. Oops, I don't want to label that independent. What am I thinking? I want to label that distance in feet, because that's what it is up here. Okay, that's what I'm labeling my table for. And then the y is the number of baskets. Now if I'm looking at my data, I want to switch to a skinny pen real quick. If I'm looking at my data, the distance goes all the way up to 28 feet. I know I can't count by ones because my table or my graph is just not going to be large enough. So I'm going to count by twos. And you should be labeling yours the same. And that worked out perfectly. So the number of baskets, let's see, the highest number I have here goes up to 14. So I'm pretty sure I can count by ones. Perfect. And that, I know my numbers are hard to read because they're so small. Hopefully yours are more legible for you. I'm going to erase this over here so you don't get confused on why that might be marked. Okay, the way I'm going to plot my data, at 14 feet, Jarrett got 4 baskets. So I'm going to come over to 14 feet and count up to 4. 1, 2, 3, 4. And this point right here represents Jared. So I'm going to make a little mark by Jared so I know that I've already plotted his so that I don't accidentally do his twice. So now I'm going to do it for Tyrell. For Tyrell, he's at 25 feet. 25 falls between 24 and 26. So I'm going to be like at the halfway point between these two. And then I'm going to go up to 6. Right there. I'm going to do the same thing for Anthony. He's at 27 and he got 7. Oops. And then Mark is at 15 feet and he got 11. CJ, 26 feet and he got 6. Kevin is at 16 feet and he got 13 baskets. Wade is at 15 feet and he got 12 baskets. Kyle's at 26 feet and he got 8. Chris is at 16 feet and got 14 baskets. And Tim is at 28 feet and got 5. I'm going to just take these little dots away so you don't think that they're data points. Okay. What type of association do you see in this scatter plot? List any other observations in the space below. So it looks like I've got a group of data up here and a group of data down here. And some might say there's no association, there's no relationship. I've got one group and a second group. But let's look at it a little bit closer. If I try to draw a line just through the middle of the data, is my line going positive or negative? Let's think about the lesson that we had yesterday. We talked about whether the variables were moving together or whether they were moving opposite. So as my x's were going up, as the distance away from the basket was getting greater, the number of baskets made were getting less. So I would say that this is, generally speaking, a negative correlation. And you can see that with that line that I've drawn, or negative association, I'm sorry. The words association and correlation are used interchangeably when we're talking about data. And when I was working in the corporate world and I was looking at things like this, we called it correlation. So I tend to say correlation a lot, and most of the math curriculum says association. So just think about those words as being very much interchangeable and being synonyms. So generally speaking, there's a negative association. The farther away you are from the basket, the fewer baskets that you're going to be able to make. And if I draw a line through here, you'll see that the line is going down when it goes from left to right. Now, there is this one piece of data that doesn't seem to fit with the rest, and that's what we're going to talk about in just a few minutes. So, number 2 says, use the scatter plot to label each statement as true or false. As the distance from the goal increases, the number of baskets made decreases. Is that true or is that false? That would be true. As the distance from the goal decreases, the number of baskets made increases. Again, that's true. That's kind of like going backwards and forwards on the trend line. So if my number of baskets are increasing, I'd be going up here. That means the number of baskets made is decreasing. I'd be right around here. If I'm going backward, then I would expect it to be I'd expect more baskets to be getting made. Okay, so part C, as the distance from the goal decreases, the number of baskets made decreases. That's not true. That one is false. So let's talk for a minute about outliers. Outliers are a point that does not fit the overall pattern or trend of the data in a scatter plot. It would be known as an outlier. This one down here, I would call my outlier because this is Jared, he is scoring significantly less than the rest of his teammates that are standing at the same distance away, or he's actually even a little bit closer. Maybe, and this is just a hypothesis, perhaps he's too close to the basket to make it accurately. Maybe he'd need to step a little bit farther away because it looks like the next closest person is actually 15 feet or 16 feet, and they are able to get many more in. I can't speak very well. So who is the outlier? It was Jared. Wah, that is not what I wanted to do. Let me undo that. Okay. So Jared, the number of baskets he made was much lower than the rest of the team. Now, the thing that actually made it a little bit difficult for us to see this correlation at first was that our data was clustered. And we were clustered in this group and clustered in this group, and then we had nothing in between here. Now, what does that mean? Well, perhaps it means there were no people standing between 20 and 22 feet away from the basket. We can hypothesize that if there were people standing between 20 and 22 feet away from the basket, they would make somewhere between, 8 and 10 baskets in 30 seconds if this trend line would continue. That's how I would use a trend line to help me make predictions. So why do you think this clustering occurred? Perhaps a group of boys stood close to the basket and a group of boys stood a distance from the basket and no one stood in between them. Okay, so clustering occurs in a scatter plot when there are distinct or separate groups of points or data points. And again, that can happen because perhaps the sample isn't complete or perhaps the data just turns out that way. Okay, so the population of 10 cities and the number of elementary schools it has is shown in the table. Make a scatter plot of the data. Now the scatter plot is already labeled for you. So the population is on the x-axis and the number of schools is on the y-axis. So the population is the thing that's independent and the number of schools we're going to say is dependent. So what I would like you to do right now is pause the video, place all of the data onto the scatter plot, and then come back and check to see if you plotted it correctly. Okay, so hopefully your scatter plot looks something like mine. This is an incredibly difficult thing to actually copy off of someone. It's actually easier for you to just make your own scatter plot. So if you didn't pause the video and you're like right now fiendishly trying to copy down where my points are, it's actually easier to take a minute, pause the video, find 76,000 or about on the X, so 76,000, it's going to be greater than 70, not quite 80, right in the middle here, and then go up to 19, which is going to be greater than 18 but not quite 20, and make your dot there. And so to trying to figure out where my points are and copy from me, you're better off just doing it on your own. So if you didn't pause the video and do that, please do that now. Now you know exactly what it should look like. And then I want you to pause the video again and answer these next few questions. Okay, here's how I answered the question. Describe any association between the variables. What conclusions can we make? There appears to be a positive association between the variables. As the population goes up, the number of elementary schools also goes up. Are there any outliers in the data? This one up here, which is Glens Falls, the population is only 20,000 and they have 20 schools. That doesn't seem to be the norm. It seems that if they would have much fewer schools if they were fitting in the trend, maybe like half as many. Is there any clustering? Meaning, is there just a group of data and then a big gap and then another group of data? And no, it's pretty consistent without the big gaps. So I would say that there is no clustering going on in this particular group of data. So what I'd like you to do, and my video is starting to run long, on Tuesday, I want you to do this next example, and we'll go over it in class the next time we're together. So on Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data collected to make a scatter plot. Now they've already labeled it for you. So the amount in their lunch account they're saying is the X, and the homework assignments they're saying is the Y. And I want you to plot the data and then answer these 3 questions, and we will talk about it in class tomorrow. The last thing that I want you to do is to go to page 6 and create a page of Cornell Notes. And on your Cornell Notes, your essential question is, how do I construct a scatter plot? And the first thing is, determine which variable is going to be the independent variable and which one's going to be the dependent variable. Remember, dependent variable changes as a result of the independent variable. When 2 variables have no association, neither variable is dependent on the other one. And at this point, most of your data tables are going to be labeled for you, or it's going to be pretty obvious which one is dependent and independent. Next, you're going to plot the data on your coordinate plane. Third, you would determine if the data shows any association. Sometimes the word association and correlation are used interchangeably. Fourth, determine if there are any clusters of data or groupings of data, and hypothesize about what might cause a data cluster. Determine if there are any outliers, pieces of data that don't fit the overall data trend, and then use the data to help you make predictions or analyze situations. That's why we use scatter plots, is we're analyzing something or using that information to make predictions. Have a good evening, and I will see you in class next time. Thanks. Bye.